right. So, ladies and gentlemen, that first question says, what does a mole tell us? So, what does a mole tell us about in an atom or a compound? What is a mole?
A atom in a specific amount of mass.
Perfect. It's the number of atoms in a specific amount of mass. Do you guys remember that giant number of atoms that a mole represents? I know a couple of you had it down.
6.022 x 10 and then the 23.
Perfect. 6.022 times 10 to the 23rd power is wonderful. Nice job. And then number 2, what is the molar mass of oxygen? What do we get?
$32 grams.
Perfect. 32 grams of oxygen is, and that tells us what? What does that equal to? Or how many moles is that equal to?
1 mole.
1 mole. Perfect. 32 grams of oxygen is equal to 1 mole. And then real quick, if we look at that little red section, it did say, remember that oxygen is a diatomic, meaning that it does not want to be alone. So if you ever find it alone, so if we ever say oxygen by itself, there do have to be 2 of them present. So make sure you're paying attention. If you ever see just oxygen by itself, we have to have O2, not just O. All right, ladies and gentlemen, so open up your assignment for today off Canvas. It should be our molar conversion introduction. So now we're actually going to start using this molar mass to do some calculations. So if you guys open it up, we can look at that first problem. It says we've been calculating the molar mass. Let's practice with it one more time. So I want you to find the molar mass of strontium chloride. The first thing, what do we have to do first before we can find the molar mass of this compound? What do we have to do before we can find the molar mass of this compound? Who has any ideas?
Get a periodic table.
Get a periodic table. Lovely. Great start. We got to figure out what the ions are. Awesome. So we have strontium and chloride. Do we know what strontium is? What's the element symbol for strontium?
SR.
SR. Perfect. And do we know the element symbol for chloride?
CL.
CL. Perfect. Now, how do we figure out how many of each we need in this formula?
Just 1.
We need 1 of each. That's it?
Yep.
You're positive?
100%.
100%. I'm not 100% positive on that one.
Oh.
We do to figure out exactly how many we need.
Oh, because we need the actual, what's it called? We have to fucking, oh, my bad. We have to solve. My bad.
We have to solve the what?
For strontium chloride.
All right, what about it?
And don't we have to get like how many you need to add up to 0?
Perfect. So we need our charges. So what's the
Yes.
charge on strontium?
Let me check.
Remember, we use our periodic table to do that.
Yeah, it's +2.
It's +2. And how'd you get +2?
Because I saw it on the periodic table.
You saw it on the periodic table, so you knew it had to be true.
Yeah.
So if we look at strontium real quick, it's right here. So we're looking at strontium. How many valence electrons does strontium have?
Two.
It has 2. How many does it want to have?
8 or 0?
It wants 8 or 0. So which one's it closer to, 8 or 0?
0.
It's closer to 0, which means it's going to get rid of its 2, which is why it does in fact have that +2 charge.
Yes, sir.
And what about chlorine? What is chlorine's charge? All right, so it has 7 valence electrons, which is great, and it wants how many?
-1.
It wants 8, so it's going to have that -1 charge. So it's a -1 and a +2. Do those add up to 0?
No, so you need another chlorine.
We
chlorine.
need perfect.
So
All right, so what's my final formula?
SR. And then parentheses Cl2.
Perfect. And you can keep those parentheses if you want. You don't have to have them. So these are both or SrCl2. Both of them are options. Whichever way you wrote it is perfect. All right, so now we have to find the molar mass. So you guys take about a minute to find that molar mass on your own.
$158.52.
All right, you said it's 158.52.
Yes, sir. Grams of, or whatever. I forgot.
Strontium chloride equals
Yeah.
what?
1 mole.
1 more. Perfect. All right, refresh me on how we did that one, just so everybody's clear on that.
So
We
we
find the
would
atomic mass of each element.
oh, no.
Perfect. All right, so we found the atomic mass of each element. Strontium's was what value? $87.62 is perfect. And then what about chlorine?
35.45.
35.4. And then we got to multiply it by 2. Perfect. Because there's 2 chlorines in here. And when you multiply it by 2, you got that 70.90. Perfect. And then we add these 2 numbers together. Nice job. Are there any questions on that? All right, so then we're going to go back to that wonderful video you guys watched at the beginning of the last unit with polyatomic naming. So hopefully we remember that. In 3 seconds, we'll watch it. Can you guys hear the video?
Yeah.
Right,
This
perfect.
is a boring old gummy bear. And this
Hopefully you
is what
remember
happens
this
when you drop
one.
it into boiling potassium chlorate. Whoa, that was awesome. But we're VAT19, and this is the world's largest gummy bear. So...
All right, I think we've seen enough of it. All right, guys, refresh my memory. What did we talk about when we did this one? We talked about, was it an endothermic or exothermic reaction? Do we remember?
Wasn't that an exo?
Exothermic. And why did we say exothermic?
Because it's releasing.
It's releasing heat. Perfect. Awesome. And then the other thing I just wanted to remind you guys is that he did say it was potassium chlorate, which is, chlorate is a what? What do we call chlorate?
It's a polyatomic.
It's a polyatomic ion. Awesome. So We used that in our last unit a lot. It was on the summative, it was in the beginning. We're going to use that again. This time, we're going to look at it. So we're looking at this, and let's find out how many moles of potassium chlorate were actually in that beaker when he did that experiment. So in order to do this, we need to follow a few steps. There's 8 of them that we're going to follow. And when we go through these steps, the first thing what we need to identify is how many moles there are in 1.35 grams of potassium chlorate. So we're going to figure out how many moles there are in just that small amount of grams. But the first thing we need to do is identify the givens, the unknown, and the pathway. So what that means is, are we going from grams to moles? Or are we going to go from moles to grams here? Based on that question, what do we think? What are we starting with? What's our given? What are the units for our given? From
Grams.
Perfect. We started with grams up here. So we're going from grams. And what's the unknown going to be? What are we looking
How
for?
many moles are going to be in 1.35?
Perfect. We're going from grams to moles. So that's just going to be our overall pathway, and that's going to be a lot more important when we get to the next unit, way in the future, called stoichiometry. This is going to be more important. But for now, we just need to go from grams to moles. We just want to find out how many moles we have. So before we can do anything else, we do need to write out that formula for potassium chlorate. So take a minute, do that on your own. All right, did anybody come up with the correct formula?
Yeah.
What'd you get?
K parentheses ClO3.
Perfect. Does anybody disagree? All right, perfect. Everybody got it right then, because potassium has that +1 charge, and chlorate is ClO3 with a -1 charge. And we know it's ClO3 and not just Cl because of that ATE at the end. All right, so step 3 says identify the molar mass of the chemical formula. So specifically, what's the molar mass of potassium chlorate? So how are we going to find that one?
Finding each element's atomic mass.
Perfect. Find each element's atomic mass. So we have potassium, chlorine, and oxygen. Who can tell me one of those molar masses?
Potassium is 39.10.
Awesome.
Oxygen is 16.
Awesome.
Wouldn't what's it called? Chlorate beat chlorine.
Yep.
So you'd have 35.45.
Perfect. All right. Do we need to multiply any of those?
Just add them. Wait, no.
Oxygen.
We got to multiply oxygen. There
Yeah.
is that 3 there. So we got to multiply this one by 3, which means let's bring those back over. 39.10, 35.45. And what is 16 times 3?
$48.
48. Awesome. So now what do we have to do?
Add them up.
Add them up. So who can tell me when we add all those up, what do we get?
122.55.
All right. And what are my units on that one?
Grams. And then K parentheses ClO3
Perfect. Equals what?
1 mole
1.
K and then ClO3.
Awesome. There we go. So we've done steps 1 through 3, and those ones are probably the easy steps. Those ones we got. We know how to write formulas. We know how to find molar mass. We can read a problem and pull out what we're given and what we're looking for. That stuff I figure is kind of older stuff. Some of it a little bit newer, but not difficult. Steps 4 through 8 is where we really get into the good stuff here with some math. And hopefully you guys like math as much as me and are so excited. But we're going to do all 5 of those last 5 steps below, all right here. So the first one says we're going to make railroad tracks or this lattice structure to set up our problem. And we're going to do this every time. And I do expect to see this as the way you're setting up your problems. And I know it's probably pretty easy just to do some multiplication or division. It wouldn't be hard. But in the future, it's going to get a little more difficult, which is why we set it up in this way. So our railroad tracks are just going to be a line down the middle. And since we only have one step, we're only going from grams to moles. That's only a 1-step problem. That means we only need to split it up in half. So this is what our railroad track is going to look like. This is step 4. Step 5 says place your given in the top left corner of the railroad tracks. So our given, instead of just putting those units, we're going to go all the way back to our problem, and we're going to take that whole number, the 1.35 grams of potassium chlorate. We're going to put that whole thing right here, 1.35 grams of potassium chlorate. How are we doing so far? Good? All right, step 6 is where we get a little bit more complicated. It says in the next column, so we're leaving this spot blank. You don't need to put anything in here. Ignore it. It doesn't exist to us anymore. In the next column, so this is where our given went. The next column is going to be our conversion factor. When I say conversion factor, things that I'm talking about, or conversion factor is a way to compare units. So one is like 12 inches is 1 foot. There are 1,000 grams in a kilogram. A third option would be there are 12.01 grams of carbon in 1 mole of carbon. So what that last one's telling us really is that our molar mass is our conversion factor. So we've created this already. We have it. All you have to do is use it. When we're using it, we got to make sure that our units are going to cancel out at the end, which means that if my units of grams are up here right now, where do you think I have to put my grams of potassium chlorate in that second column? Are they going to go on top or on the bottom? What are your thoughts? Take a guess. You got a 50-50 shot.
On the top.
All right, he said on the top, so we're going to put them right there. Does everybody agree? Does anybody want to say it on the bottom? All right, it sounds like everybody agrees since nobody said anything different. So what we're going to do is we're going to take these two things, the 125.55 grams of potassium chlorate and the 1 mole of potassium chlorate. One of them goes on the top, one of them goes on the bottom. So he said put the grams on top. And so let's do that. So 125.55 grams of KClO3 over 1 mole of KClO3. Once we do that, what we're going to do is we're going to multiply everything on the top together. We're going to multiply everything on the bottom together. So what that looks like is we are going to have 1.35. And I'm going to put units on this first one. In the future, I'm not going to, just because we don't actually need to put the units back on until the end, as this is just a small step. So 1.35 grams of KClO3 times 1.2 or 125, sorry, 125.55 grams of KClO3 divided by 1 mole of KClO3. And so we're going to multiply everything on top, and then we're going to divide it by the number on the bottom. All right? So looking at this, do we agree still that the grams of potassium chlorate, that 125 in our conversion factor, do we agree that it goes on top and that the moles go on the bottom? Or do we want to change it? What do we think? All right, so
It's good.
it's good. I'm going to say no. And the reason I'm going to say no, which it's fine, we took a guess, it was fine, 50-50 shot. The reason I'm going to flip these is because when we look at this in terms over here, when we flip that, we can see that now over here, this also gets flipped. So this goes up here, this goes down here. And so now, once we do this multiplication, so we'll get 1.35 grams of KClO3 times moles of KClO3. I'm gonna have to move that over. Divided by our 122.55 grams of KClO3. Just like in math class with our X's and Y's, those variables, what happens if you see the same thing on top and on bottom of a division line? What's going to happen to our grams of KClO3?
Cancel out.
They cancel out, which means the only units we have left are what? What units are left over here?
Mole KClO3.
Perfect. Yeah, our only units left are going to be those moles of KClO3. So the only thing we have left in that equation as far as the units is just the moles, which is what we're trying to get to. If you remember from up here, that's what we're trying to get to in the end. So if we have the grams up at the top and the grams at the bottom, these guys are going to cancel out and leave us just with our units we're looking for. So when you have these railroad tracks, we always want our units to go from top to the bottom so that it can cancel out. Does that make sense? Anybody have any questions on that? I'm just going to slide this all over. Just so it looks. Sorry, started writing small. How do we feel on this?
Decent.
Decent. All right. So what the rest of the class today, you got two options. So we have a formative, and that formative is just on finding the molar mass. You can finish that up today and then work on this tomorrow at the beginning of class. Or what you can do is finish up these two problems down here. There's two of them. follow the 8 steps from up above to solve these 2 problems. And then tomorrow, take the formative. So you have both options, or you do them both today. And then tomorrow we do have another assignment that'll roll over into Monday, so you'll have time. But those are the 2 things